Okay, so I want to do a QR decomposition of a matrix A here given by 1, 1, 1, 2, okay? And I want to use the Householder transformation to do that. Okay, so remember the formula for the Householder transformation, which is given here. Okay, so I will need to find my parameter u here, which is given by x minus x prime, where x is the first column vector of A. Okay, so this column here. Okay, this one. So x is 1, 1, and x prime has as first component the norm of x, so square root of 2, okay? Square root of 1 squared plus 1 squared, which is square root of 2, and all other components are 0, okay? So the second component is 0, okay? And the first is, as said, the norm of this vector here, okay? So u is given by x minus x prime, so that will give us u is equal to 1 minus square root of 2 and 1, okay? This result here, okay? All we need to do is use this formula where x is the first column vector of A, or the column vector that you are that you need to use, and the x prime has as first component the norm of that column vector, and as first component, and all other components are 0, okay? So now we can use our formula here, okay? So given that you are in 2 dimensions, okay, A is a 2 by 2 matrix, the identity matrix will also be a 2 by 2 matrix, okay? So here we have our identity matrix in 2 by 2 dimensions, and here we have our vector u here, okay, and its transpose here. And remember, we divide by u transpose u, okay? So here, which is actually the dot product of the vector u with itself, okay? So if we do that, we have the first component squared, so 1 minus square root of 2 squared, plus the second component squared, so plus 1 squared, okay? And so that will give us the following matrix, which will be our Householder matrix. Okay, you can do the calculation on your own, or plug that in a calculator. Okay, you should get that result here. So 1 over square root of 2, 1 over square root of 2, 1 over square root of 2, and negative 1 over square root of 2. Okay, now we apply it to our matrix A. Okay, and as expected, only the first component of the first column vector is non-zero, okay, which is the norm of the old column vector here, okay, it's the norm. As I said, it's x prime basically, okay, and the second component is now 0 as we wished, okay, and that is actually our upper triangle matrix R, okay. That's all we need to do. So this upper triangle matrix is square root of 2, 3 over square root of 2, 0, and negative 1 over square root of 2, okay. Now remember that A is equal to QR, and Q transpose A is equal to R, okay, because Q is orthogonal, okay, so its inverse is its transpose. So given that we know that our first and unique Householder transformation applied to A gives R, and that you also know that Q transpose A is equal to R, we know that Q is equal to our Householder transformation transpose, okay? So it's basically this matrix here, simply we transpose it, okay? So basically it changes absolutely nothing, because this element here and this element here are exactly the same visually, but you should switch them to get the transpose, okay? But yeah, you should get that, you should use that to get your Q if you want. And your R is, as I said, already what you want here. And now visually what we did basically is we took the first column vector of our matrix A, okay, so this X, so the vector 1, 1, okay, which is here. I hope you can see it. And we reflected it in such a way that the new vector x prime only has one non-zero component, and this non-zero component is the norm of the old vector. Okay, so basically what we did is we reflected this this vector x here in such a way across a hyperplane that we need that we need. But we don't really need to compute it or whatever. But we reflected it in such a way that now it lies on this coordinate axis, okay? And so if it lies on this coordinate axis, only the one component is non-zero and the other are 0, and that's what we wanted, okay? So I hope this video is clear, okay? So that here is the visual interpretation. So you just reflected your vector such that one at the end, the reflection has only one non-zero component, okay? So basically you sort of not projected it on an axis, but you made so that the reflection lies on one coordinate axis, okay? So this one basically. And yeah, and so that is our example in 2 dimensions. I hope this video was helpful to you.